Hello everyone, welcome back to episode 2 of this series exploring how to solve mathematical and computer science problems with AI. So now we're on to project Euler problem number 2, the even Fibonacci numbers. So each new term in the Fibonacci sequence is generated by adding the previous two terms. Starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. By considering the terms in the Fibonacci sequence whose values do not exceed n, find the sum of the even valued terms. Okay, and then if we look down here, it will give us up to 100,000 test cases, and the largest one will be 4 times 10 to the 16. So that's a vast number. If 10 to the 12 is a trillion, 10 to the 15 is a quadrillion, so I think that's 40 quadrillion, I think. Yeah, so these are the samples it gives. It has 2 test cases, 10 and 100, and the answers expecting are 10 and 44, and it explains down here that if n is 10, the only 2 Fibonacci numbers below 10, so 10 cuts off here, the even ones are 2 and 8, and the sum is 10, and for n equals 100 you have 2 and 8 and 34. And it's interesting that most of the Fibonacci sequence is odd. That's somewhat surprising maybe. And some interesting historical digressions about Fibonacci, which I didn't know before I looked this up. Fibonacci, 1170 to 1240 or 50, so very ancient, nearly 900 years ago now, or in the Middle Ages. Known by several other names, Leonardo Fibonacci, Leonardo of Pisa, an Italian mathematician from Pisa, the most talented Western mathematician of the Middle Ages, which is a big claim. He is commonly called Fibonacci, and that was made up by the historian, don't know how to pronounce it, Girolamo Libri, and it's short for Filius Bonacci. So Filius is son in Latin, so Filius Bonacci, son of Bonacci, which I didn't know. Even earlier in 1506, he's mentioned as Leonardo Fibonacci. So maybe there's some tradition of this Fibonacci, and I guess if he was from Scandinavia, he'd be called Bonacci-san, or something like that. And one thing I didn't know is that he popularized the Hindu-Arabic numeral system in the Western world, primarily through his composition in 1202 of Liber Abaci, so the book of calculations, so abaci, similar from abacus. Yeah, which is an amazingly huge contribution, because now, I mean, that number system is everywhere. Yeah, and if we look down, there's a page from the book that he wrote, like very beautiful, ornate Middle Ages manuscript. And in a Liber Inacci, he introduced the so-called modus indorum. So interestingly, they knew that this had come from India, rather than, I've always been told it's the Arabic numeral system, but it's the Hindu-Arabic numeral system because it originates in India, and it has 0 and positional notation. And it says it replaces Roman numerals and its ancient multiplication method. Because Roman numerals are a bit weird because you can modify a number by putting something before it or after it. So like ix is 9, and that's kind of not very good. You want like a single digit that's not going to change. It makes it much easier to do calculations. And the book also discusses irrational numbers, which were known to the ancient Greeks, and prime numbers. So amazing good. And he created the sequence, which is named after him. Okay, so I've copied in the explanation to Codex. That was just what we read. And I've copied in the sample code. And so let's see what Codex comes up with. Okay, so it's finished it. So it says the first element is 1, a equals 1, and then b equals 2, which is correct. And then it says start with c is 0, and the sum is 0. And it says while c is less than n, make c equal to a plus b. That's how you generate the Fibonacci series, the sum of the 2 preceding terms. Check if it's even. If it is, add it to the sum, and then shuffle forward. So a becomes b becomes c, and then you begin again with c will become a plus b. So let's take this and let's put it into here and run the code and see what it does. Okay, so it says that it's a wrong answer. And our output is 8 and 186, and the expected output is 10 and 44. And so I think if we go back and look at this, it seems very reasonable at first glance, but I think there are some problems with this code. So for instance, it says while c is less than n. So it will check this when it comes to the end of the loop. And at the beginning of the loop, it will say c equals a plus b. So let's say we get to this point where a is 55 and b is 89, and c, which was last set here, will still be 89 because B is set to 89 here, and so C is still 89. So it begins the loop, and C is 89, so it's fine, and it says, yes, continue to do this. But then it says C is A plus B, so it adds it together, and it adds these on and gets 144, which would be the next term in the sequence, and then looks at it and says, yes, this is equal, and then adds it onto the sum. So for example, for this one, we're quite a lot too high because I think we've added on 144 more than we should have had. So we're too short, and then on this second one, we're 144 too high. So it's kind of gone wrong, right? Which is not so good. And it's also having problems at the beginning of the sequence because it says A equals 1, B is 2, and C is 0. So the first value of C is going to be 3, but actually 2 is an even number, and 2 is going to be less than n almost all of the time. So we need to include that too, whereas actually C is never equal to 2, and so that's not getting added on. So this is why this first one is 8, because rather than getting 2 and 8, we only have just the 8. So that explains why this is only 8, and that explains why this is, it's missing the 2, so it should be 188, and then that's 144 greater than 44. So we're adding on the 144 we shouldn't be, and we're missing the 2. Okay, so let's see if we can reword this a little bit to help the AI out. So I think this second sentence is a little bit flowery maybe, and it's a bit too complicated for it to understand. So maybe if I change this to calculate all the Fibonacci numbers less than n, and then sum the even ones. So it's giving it a bit more explicit instruction. It says calculate which Fibonacci numbers are in this range, and then sum up the ones which are even. Okay, so let's try that, see what it does. Okay, so now what it's done is it said, okay, I'll start with some list with 1 and 2 in it, and then I'll check if the last one is still less than n, and if it is, I will add on another Fibonacci number. So I'll take the last one and the second to last one, in this case it'll be 2 and 1, and then I will check the sum and add all the even ones. So let's see if this is better. So it's generating the sequence first, properly, and then summing up the, to see whether all the numbers are even. So let's see if that works better. I pressed Control C rather than Control V when I meant to. It's funny that there's this enormously powerful, brilliant AI at my fingertips, and then it's me pressing the wrong buttons, which is the thing that holds it up the most. Okay, so it doesn't like this, right? Because it's still making this mistake of it's adding on 188, and so it's checking, this is again the same problem, right? It's checking, is the last one less than n, in which case it finds 89 is the last one, okay, fine. So then add another Fibonacci number on. But the problem is that in this case, you shouldn't add another Fibonacci number on, okay? So we need to try and convince it not to add the whole list like that, okay? So maybe I'll just run it again and see if it comes up with something different, because the AI is capable of doing different things differently each time. Okay, so it's done exactly the same thing again. So we need to say, calculate all the Fibonacci numbers strictly. I wonder if that will help. We're trying to kind of convince it, like, please don't put 144 in. So yeah, so this is incorrect. And I could help it by hand maybe, and I could say, because we know that this will only terminate when the last one is greater than n, and so we kind of want to knock the last one off. But that's not really that helpful. And we could again change it in here. We could say x for x in Fibonacci, but don't do the last one. But it would be nice if we could get the AI to solve it. Okay, maybe I'll ask it, calculate the even Fibonacci numbers less than n and then sum them. Let's see if that wording helps it. Okay, now it's gone back to this method, which is the original method it started with. So again, it's probably one of the issues is the way that AI has learned is it's looked at this giant code base and it's probably found these two sequences for generating Fibonacci numbers, and this is what it looks for when it comes to these things. Okay. So let's try. Let's keep digging around inside it and see if we can get it to figure out this problem that it's got the last number too high. Compute the Fibonacci sequence up to n. Then sum the even numbers. Then sum the even members. Okay, let's see if it likes that. Because I didn't want to say then sum the even numbers because that's a bit confusing. Okay, so now we're back stuck in this little loop. Okay, so the AI is kind of struggling here. It can't. Oh. Now why does that work? Now it's me that's struggling. Now I'm confused. There we go. It's got this in the sum now. I can't remember when it did that. Maybe it's me that didn't notice. So it's saying when you sum this up, make sure it's even and make sure it's less than n. So it will create the sequence with the last number, which is greater than n, but then it will only include it if it's less. Okay, so that's much better. There we go. So I think I was kind of unfairly besmirching the AI. I was saying that it wasn't working when actually it was. So maybe that's my fault. I think this is probably the moral of the story when it comes to developing these complex systems, where more and more it feels like I'm the stupid one in the loop. You know, my old PhD supervisor used to say mathematics is a great subject to study if you want to feel stupid. Okay, so there we go. Congratulations to Codex. It's managed to solve the second problem, and I hope that was interesting with some interesting historical digressions about Fibonacci. All right, thanks for watching.